Okay, like I mentioned last time, I'm going to wander through this sort of synchronous, it's not quite the same as an in-class lecture, but it's the best I can. All right, so if we can hold to these regular synchronous meetings, then at least students can ask questions. It can almost be like a office hours type thing, but I do plan to lecture during that. Again, if you miss any of this, these Zoom meetings are recorded. All right, once I finish the Zoom lecture, it takes a few minutes for it to actually, because it's rather big, it takes a few minutes to download to my computer. So I'll make it available in that Zoom meeting folder that's on Blackboard. Again, it's under the content tab. As soon as these get saved to my computer, then I'll get them loaded. Sometimes that takes 30 minutes to an hour. All right, if you don't happen to see that Zoom meeting after an hour or two, or maybe later that afternoon, then shoot me an email. Something may have occurred. But again, the Zoom meetings for any of these things should be posted. The reason I've done that is, again, for those people that want to use this like a classroom, stick to a schedule. To me, it's kind of like sitting in a classroom, taking notes, being able to answer questions. With that being said, it's good because if you miss any of that, they're recorded. So you can go back to these videos and you can pause and go to portions that you might have missed or want to review and whatnot. And then for those people that miss it, you can go back to that and just watch it from the start. And again, it gives you an opportunity to pause and look at the areas that you have need to review or that you have questions about. And if during any of that, even whether you're present now or whether you're viewing it later, if something comes up, if you have questions, if something's not clear, just reach out, send me an email, and we'll work through it. So this isn't your only opportunity to ask questions. Just again, if you do, it's better to reach out early rather than later. So that being said, let me jump into see if our lecture for the day can work. Okay, awesome. What we have here is, again, I gave you that Invisible Body. It was Introduction to the Human Body. That was posted. Again, I hope you've got access to Visible Body. If you have not, I sent the link. Please get registered for Visible Body. What I then asked you to do is start working through that introduction, and I gave you some guided notes. This is what you see here. And again, I mentioned this morning that it's broken down to what ends up being lecture 1. And then if we go through this, you can wander through lecture 1 and get into lecture 2 and whatnot. So I'm going to spend a good portion of the day sort of quickly wandering through this because again, as we go, there are things I'm wanting you to do at home, using Visible Body and answering a lot of these questions on your own. I then will highlight it with my own lecture and information. And again, all of that stuff, anything I mentioned is fair game. Again, I think it should be reasonable. The good thing about today's lecture is I think a good portion of this terminology is going to overlap with some things you're doing in lab. So it's sort of a 2-for-1, if you will. All right. So with that being said, I want to wander through and make sure people don't have questions about the things that they saw in this Visible Body. Again, if you haven't done it, you need to do so soon. We're in summertime. And again, it goes by quickly. There's an awful lot. Again, you're in, ideally, if we were in the classroom, you would be here for 2 hours wandering through information. So you're supposed to spend some time at home working through this. I'm going to give you some more Visible Body stuff to do as we progress. All right, so here we are. If you wander through this anatomical terminology, it listed a bunch of questions and things that you should try to basically understand. All right. One of those being said is, what, first question, how can we use anatomical terminology to describe body parts? Why do we use that? All right. Well, what they're getting you or wanting you to look at or try to understand is a couple of things here. Let me see if this will work here. Awesome. All right. How can we use anatomical terminology to describe body parts? Well, we can look at this in 2 regards, all right? When we talk about this class being anatomy and physiology and talk about anatomical terminology, that's broken into anatomy and physiology. As a side note, I very, very much apologize for my handwriting. It's probably this bad when I'm in the classroom as well, so sorry for that. If you have trouble reading something, let me know and I'll try to highlight. All right, when we talk about anatomy, anatomy is the study of the structures of the body. And so we use the terminology to define the different structures of the body. All right, physiology then takes those structures and investigates how they work. So physiology focuses on functioning. Now, when it's asking how we can use anatomical terminology to describe body parts, what you're saying is, at what level and where does this terminology relate? Well, there's a couple of things then. Hey, I don't know how that does that. Whatever. All right. Well, if we focus first on the anatomy side of things, then we can break anatomy terminology wise into a couple of levels. We can look at things at the macroscopic level. All right. And so we can use macroscopic terminology. What that means is essentially it's stuff that you can see. You do not need a microscope in order to investigate and describe what it is you're looking at. In addition to macroscopic, there is microscopic. Microscope is basically too small to be seen with the unaided eye, so it requires the use of a microscope. Now, this oftentimes gets broken down into then sublevels, all right, to investigate and use terminology to explain specific parts of the body at a microscopic level. For example, all right, we can use a microscope to investigate cells of the body. That is called cytology. Cyte means cell, ology means study of cells. We can use a microscope to study tissues. That is histology. All right, so you can use this anatomy area to essentially look at macroscopic levels of things, microscopic levels of things. We may use those to look at and investigate regional anatomical structures. All right. In other words, you're studying and using the terminology in regions of the body. So for example, I may want to look at all of the muscles and bones and vessels, say, of your leg, all right, and see how those are essentially working together. So I might describe an entire region and all the structures within that region. In addition to that, instead, we may use anatomy and study things at the systemic level. In this regard, you study the system of the body and look at all the things that make up that system. For example, I may study the cardiovascular system. In other words, I would use anatomical terminology to study, to investigate the entire cardiovascular system. I may look at the heart and all the parts of the heart. I may look at your blood, which flows through the heart. I may look at the blood vessels, being the arteries, the veins, the capillaries. And so in an anatomy sense, we can use terminology to describe those parts at many different levels. All right, that's a little bit different than physiology. Physiology essentially uses terminology to describe how things function. All right, and we can look at that at different levels. For example, we could say there's renal physiology. So I can use the appropriate terminology to study the renal system. That again is going to be your kidneys, your urinary system, and how all of those structures then work together for certain functioning. As you go on, whether it's AP1 or AP2, you'll introduce these anatomical features and then study the physiology of them. So we'll talk about the anatomy of the renal system, your glomerulus or a Bowman's capsule or something like that, to then describe how the renal system works. All right. Instead of the renal system, it may be that we're studying your neurophysiology. All right. We get to do that in A&P1. It is the brain and all of your spine and nervous system structures and how they have anatomical structures that then functionally work together to maintain your nervous system. All right, so this is what they want when they talk about a big idea, how we can use anatomical terminology. It's in regards to anatomical things and physiology things with the goal of using precise terminology to describe structures and then be able to look at how they function. All right, one of the things we talk about in anatomy and physiology is you are in a class, and this is A and P, anatomy and physiology. You are not just in an anatomy class. You are not just in a physiology class. You are in an A and P class. Now, it's introductory, but what that means is we talk about complementarity. A and P complement one another, all right? Yeah, we could just look at the anatomy of stuff. I can study all of these structures, all right? Now look, let's use the example I often use in class. take a mechanic, for example. All right, a mechanic, he can learn the parts of your car. That would be the anatomy. That's great because I can then describe all the parts of your car. Well, do you think a mechanic would be very good if all he knows is the parts of the car? Take someone that's a computer tech. Okay, I know all the parts of a computer. That's great. By itself, I can learn all the parts of the computer. But I also need to know then how those parts work. I need to understand the physiology, the functioning, to know how they work together, to be able to diagnose when your computer doesn't work, to be able to diagnose when your car doesn't work. And that's the same thing for you, whether it's you're becoming a nurse or a doctor or something else. Anatomy and physiology complement one another. We learn the structures so that we can then explain the physiology, the functioning, and hopefully then we can understand when the functioning doesn't go right. Where then and what structure should we look at to try to see what has gone wrong? All right, now the overlap and all of that stuff is I hope that that sort of compares and contrasts anatomy and physiology. So I think I've answered this question in the general portion as well. Now, if we move on, we can describe the levels of organization of the human body. All right, again, I'm going to now start moving a little bit more. I hope that wasn't too quick, but I'm going to highlight and make sure you don't have questions or I'm going to explain where you can find some of the answers to this. When it talks about describing levels of organization, this is basically describing the human body in terms of its simple to its complex. All right? So we go from simplicity up to the complex, all right? You as a human are a complex structure, but you are simply made of chemicals. So when we describe the levels of organization of the body, we start at the chemical level. You are simply made of chemicals, elements, molecules, atoms, and all that kind of stuff. You are made of matter, if you will, like all things on this planet. My point here is you as a human are much more than chemicals. Chemicals. We then get to a cellular level. You are made of cells. Cells, the smallest unit of life. A single cell can maintain life. Chemicals by themselves do not. Cells are the smallest unit of life. And you as a human are made of cells. And that gets a little bit more complex than your chemical level. And cells can be grouped into tissues. A tissue is more than one cell with a common function. Tissues are then organized into organs. An organ is more than one tissue. So 2 tissues or more that have a more complex function. All right? We get at the organ level that we can really start beginning to see levels of complexity. All right? And from the organ, you have an organ system. And your organ system is more than one organ that works together. Your cardiovascular system, all of the organs of your cardiovascular division. That would be the heart, that would be the blood, that would be arteries, that would be veins. All of those are separate organs within that system, and they work together to pump blood. All right? And we put all the organ systems together to make the organism. And for anatomy and physiology in this class, that would be the human. All right, so we've worked from the simple to the complex. All right, next is all the organ systems. I'm going to describe the organ systems. There are 11 organ systems. If you're not familiar with them, look them up. It should be easy to find online or in your book. But for those organ systems, I'm going to basically take time in this class. What I get you for A&P1 is doing all this foundation introductory stuff, chemicals, cells, tissues, and organ. I then, because I have to do all this background, only get you for a couple. There are 11 organ systems, and I basically get you for 4. I'm going to get you for the integumentary system. That would be your skin. I get you for the skeletal system. That's your bones and stuff. I get you for the muscular system. I hope that's obvious, your muscles. And I get you for the nervous system. That'd be your brain and junk. So 4. You would then go on to ANP2, where they spend time going through the remaining 7 organ systems. All right, so anatomical terminology. Okay, before I get started, are we all okay? See, there's no questions in the chat session. Okay. All right. So, anatomical terminology. Why do we use it? Okay. First and foremost, it allows for a precise but concise way to explain the body. All right. It allows you to very simply explain it, so hopefully everybody knows what you're talking about with limited words being used. Precision. All right. Stop this for a sec. So in other words, all right, it's a simplistic way, but it's a precise way to say exactly what I'm describing with minimum use of words. All right. Your body as a whole is made up of all these different parts. So to get people to understand, it's easier if you can use a set system of words to describe what it is we're talking about. It would be no different than this coffee cup. You know the parts. All right, sure. Hey, the handle of the cup. Everybody know what I'm talking about? The handle. The top of the cup. That's where my coffee is. The bottom of the cup, where I set it down. Look. Handle. One word, and you know exactly what it is I'm looking for. Let's take a different thing. Words, you know, an ear. Oh, yeah, right there. All right, so we're going to use some of this other terminology to essentially do the same type of thing with the entire body, so you quickly understand and can describe something or know what to look for. That is the goal and why we use anatomical terminology. All right, what is the anatomical position? Crap, I should let your anatomical position. Let's do a couple of things there. I got to stop sharing again. All right, a picture is worth 1,000 words. And I think in your book, it should have shown you the anatomical position. Here's the anatomical position. I know you can't see them, sorry, but here's how that's described. Imagine a person standing in front of you. All right, the anatomical definition for that, the anatomical position would be you are standing erect with your eyes facing forward. All right, your hands and arms are to the side with your palms facing forward and your feet together. That's a complete definition for the anatomical position. All right, now another note. When we talk about the anatomical position, I don't care whether you were laying face up, face down. All right, that adds 2 different words. Let me add those in. When we talk about the anatomical position, in addition to that, we can add the words, if it wasn't in your thing, supine. That means to be lying face up. Even the word there, see, supine, I'm face up. Prone, you were face down. So you come across a dead body. Is it lying face up or is it lying face down? The supine, prone, a lot of times the doctor comes, views you, asks you to lay down on the table. Are you lying face up or are you lying face down? That is the supine or the prone position. Now, again, when we use anatomical terminology, it's always in relation to you and your body, not someone looking at you. In other words, here we go. We're going waving at you. What arm is this? It is my right arm. Raise your right arm. All right. Now, I don't care if I spin around this direction. It is still my right arm. So if you go in and you have to have surgery and say the doctor needs to remove the kidney, your right kidney, hopefully he knows it's your right kidney, that one. All right. That's the importance of the anatomical positions in relation to you, your right, your left, no matter whether you are supine or in the prone position. All right, I'm going to pause here for a second. Define the following terms. There is a giant list of terms on here. All right, your OpenStax book or visible body goes through and defines each of these and asks you to use them or explain them. All right, you should be able to do that and use examples or find examples of how to do that. All right. Let me explain sort of what I mean, all right? We have anterior, we have posterior, anterior, the front or towards the front, posterior, the back or towards the back, all right? My chest is anterior compared to my back. My back is posterior compared to my chest, all right? So you should be able to do those for those terms. If you have a question about them, reach out and let me know. All right, I'm going to highlight a couple that sometimes you have trouble with. Ipsilateral and contralateral. This oftentimes is used when we're talking about levels of the nervous system. I haven't seen it a whole lot out of that. But ipsilateral means same side of the body. Contralateral means opposite sides of the body. I'm going to give you the easiest example, and it relates to this contralateral. All right. Imagine you have damaged some area of the left area of your brain, and you notice your right side doesn't work. That's contralateral. It is that the left half of your brain is controlling the right half of your body and vice versa. If it was the left half was controlling the left side, that would be ipsilateral. You tend to see those words used in that regard. All right. So these are often used, and you need some relation or reference point. Proximal and distal, sometimes you struggle with. All right. Proximal and distal are often used in terms of a point of attachment, a POA, point of attachment. Proximal and distal. There are two main places you see proximal and distal. All right. We use it in terms of your appendages, that's your arms and legs. So a lot of times with your appendicular skeleton. And you also see it with the nervous system. Here's where you see it. It's referring to or explaining something's relation to its point of attachment, or you may see point of origin, POO. All right, let me try to give you an example. Stop share here again so you can try to see what I'm talking about. I hope I am. All right, proximal means closer to the point of attachment. Distal means further from the point of attachment. My arm, if we're talking about the point of attachment, the shoulder is where it attaches to my main frame. So when I'm using that word proximal or distal, I can say my elbow would be proximal if we're comparing it to my wrist. That's what I mean in terms of using a reference point. So my elbow is closer to the point of attachment than my wrist is. All right, now here, my wrist would be proximal compared to my fingers. It is closer to the point of attachment. My fingers would be distal compared to my wrist. My wrist would be distal compared to my elbow. All right, you see that in terms of reference to the point of attachment. That's true whether it's my arm, that's true whether it's my leg. You also see it in the nervous system. You see it in the nervous system in terms of a neuron, the wires of the body. And whether the wires are way out here in the periphery in your arms or legs, or whether the wires are attaching to your spinal cord or brain. It just talks about a place, all right? And so think of it here as the point of attachment and where that point of attachment is. That's what proximal and distal is, and that's the two main places that you see it. All right. All right, otherwise, I think most of those are pretty straightforward. You should have gotten most of those. Like these last couple right here, cranial. is a lot of times used interchangeably with superior, all right? Cranial, towards the head. Superior means above or towards the top. Cranial, just as we're specifically saying, towards the head or the head area. Caudal means tail, towards the tail. That would relate to inferior, which means below, all right? So in other words, my head is superior to my hips. My hips would be inferior to my head. I could also say my chin is cranially located. My hips are caudally located. So I think that wanders through that. Rostral just means towards the front as well. It's weird when a lot of times when we say rostral, that relates specifically to the brain area, rostrally located on the brain, for example. So there's a couple that are overlapping, used interchangeably. So take a look at that or reach out if you have questions about those. All right. It then asks you to go on and essentially look at different planes of the body. And then we were asked to practice and whatnot. I'm going to pause here because I'm going to do a lecture now that sort of wanders through, or use a different thing to sort of wander through. If you haven't gotten this far, if you did get this far, it should be overview, and continue to work through some of these things that you see here. So with that being said, I want to go over to this other. All right, that next portion of that guided reading for visible talks about the planes of the body. So I want to sort of explain the planes of the body and see if I can get you to understand how the definition, what the definition is versus what it is you see. And so I'm going to use this picture here that's a little different than what I saw in visible body to try to highlight what it is we mean. There are 3 planes of the body. And so what you see here in this picture are those 3 planes. There's a sagittal plane, there's a coronal plane, and there's a transverse plane. Now, as a side note, transverse has some different meanings or has some additional ways they may use it, and coronal also. I'll talk about that as we go through this. Let's start with sagittal. Sagittal just means to divide the body from left to right. It is a section that divides the body into a left and a right. So you can see the plane here, right here, and it is coming in and would cut you down to divide you in a left side or a right side, right? Now, when we talk about mid-sagittal means an equal left and right half. So please forgive me, I don't have the drawing here, so I'm not an artist. Here's your body. I know, you can laugh if you want. Oh my goodness, I'm really thin. And I got big arms. All right, if you're a mid-sagittal section, then it goes straight down the middle. It divides you into an equal left and right half. If you're parasagittal, then it's unequal. It would say, like, for example, I cut you right here so that you have your arm and then the rest of your torso over here. That is parasagittal. It creates an unequal left and right. A frontal section divides you from front to back. In other words, it's cutting you in this regard into an anterior and a posterior. So if I cut you in a coronal section, I would cut you so that you have your anterior chest and your posterior back. That would be a coronal or frontal section. All right, we call it a frontal section because it cuts you from front to back. All right, next one is transverse. Transverse oftentimes also has some other terms it uses. You may see axial section or axial plane. You may see horizontal plane. You actually may even see a cross section. All right. All right. Those are all interchangeable with transverse. A transverse section cuts you from top to bottom. That would be from superior to inferior, or cranially to caudally. All right. So slicing you from top to bottom. Okay. So Those are the definitions. Now, the thing you'll miss sometimes is the definition doesn't necessarily describe what it is you see. So I have some pictures here to try to show you what that means. All right? And so you see 3 pictures here. All right? This is obviously taking some plane of the body through the head. Now, I want you to look at those pictures and see if you can say what plane that is versus that is versus that is. I'm not going to provide the answer right now. I want you to all think about it, and we'll try to come back to that maybe next week, or reach out by email and see if you have. Ask me if you've done this correctly. I want you to think about this and see if you can come up with each one of those. All right, I'm going to do a different example here in a second too, though. Take, for example, a transverse section versus what it is you see. Now, in this picture, and this may help you with the above thing right here, this is a picture of the transverse section. It has cut you from top to bottom. All right. Now, if I asked you to draw what you see, a lot of times if I took this picture, what students draw is you'd have, and work with me, like that portion, and then here's the rest of his body here. So I've tried to draw that and that. Cool, that's the cross section. That is the definition. Notice, this though is what you see. You have to take it and turn that image to view. Now, I should have thought of this ahead of time, but give me a second. I'm going to try to show you sort of what I mean, and you can do this at home. Give me just a second because I didn't think to bring it. Just take 1 second. Okay, sorry. Okay, definition is not what you see. It's one of the biggest things students miss all the time. You've got to understand that it's not that the definition that we just do left to right, top to bottom, front to back. It's not necessarily what you see. So you can do this and practice it at home, and I'm going to give you the example of what I mean. A loaf of bread. Okay, now first you have to start with the anatomical position, right? So we have to come up with what the anatomical position is for this loaf of bread. That's different. I know what the anatomical position is, but we need a reference point. So let's say that this is your anatomical position for the loaf of bread. Okay, sitting here like this. Now, what we could do is sort of describe then the different planes of the body. What would be a sagittal section? Well, it divides it from left to right. Okay, so if we did this and divide it from left to right, I'm making a cut down, I'm making a cut down the center here. Okay, the important thing here to note is that's not what it is we're looking at. That's not what the doctor sees. Here's what I mean. I've just taken and made a parasagittal section. See, parasagittal, that's it. It's divided in an unequal left and right. But here's what I mean. What we see, when I ask, what is the doctor, why would you do this? It's because you want to look at what's on that surface. All right? What's on that surface? So you may take a section that divides you like this, divide your skull down the middle so I can look in there and see the parts of your brain and whatnot. So I've just made the cut, but I make this cut because when I make a sandwich, I'm going to pile it on this, for example. And we should know that each one is different from the next. So I have made another parasagittal cut. All right. So now I have these parasagittal sections. All right. But this is what I'm looking at. And you can see that this piece is different than this piece. Nobody wants the butt end. All right. That's where I load my meat. All right. For that sandwich. So that cut, all right, is what it means to be sagittal. All right. You divide it from left to right, but the view you're looking at takes it to and turns it to look at it. All right. In other words, you may take and cut it like this, but you don't butter this part. You butter that part. That's the part that you're after. Okay. Now, that is different. I'm going to ruin the whole thing. Now, that is very different than if we took, say, a transverse section. All right. And you should also recognize, and that's a completely different view than our sagittal. All right. If we took a transverse section, then I'm sawing it this direction. All right. I'm not going to cut this one because I have to do one more. But my point here is you've all seen it. I would cut it this direction, and you could then, like I've cut it so that you have a top and a bottom, right? Can you all picture that, right? A top, I've cut this and you have a top and a bottom. And you know where you load the meat. You don't want to look at is that part where all the meat, you've just made a hoagie. All right. That view is very different than the definition. I've sliced it this way, but then I'm going to turn and look at that interior. Just like we saw for the human body. I've cut you through here, but I'm not wanting to look at your head top. I'm wanting to see what's in that view. So you turn it to look at it. Again, I make the slice from top to bottom so that then I can load all the meat on that portion I'm wanting to view. And that is very different than a frontal section. All right. A frontal section is front to back. So now I'm slicing it. From front to back. You can see that front to back, right? And what are you wanting to look at? Well, I want to see what's in there. So I hope you recognize that all of these definitions, whether it's front to back, left to right, you know, sagittal or top to bottom, transverse, provide very much different views of the body for the different planes. Find a piece of bread at home. You can practice that if you will. All right, use something else. I can do it with my coffee cup if you would. All right, a transverse section. I'm going to slice through this way. All right, a frontal section. I'm going to slice through this direction. All right, a sagittal section. I'm going to slice this direction. And then what view would you see in each of those? Make sure that you understand and recognize that. Take a look at pictures in the book. Take a look at pictures online. Make sure you understand that concept. All right. Moving along. Okay, before I get to compartmentation, I want to come back real quickly and highlight a couple other things that are outlined in that note section to make sure people got what it is they were we were trying to work through. In other words, whoops. All right, we were working through this. It asked you to do axial and appendicular and get some of those parts and whatnot. All right, and I have this in my note in the other notes and a little, so it's a little repetitive, but I'm trying to work hand in hand with what ends up being the visible body outline. So this is that visible body outline, coming back to that. Basically says we can divide the body into different regions. All right, there's two main regions. There's an axial and an appendicular. When we talk about axial, it means your main trunk. It's your head and basically your vertebrae and torso, your head and chest down through the abdomen, if you will, or in the pelvic girdle. Your appendicular region, it's all your arms, your appendages, your arms and your legs, okay? That's the basic way to describe those. You should then work through this terms right here and being able to fill in that. I'm not gonna do that for you as well. If you have questions, let me know. All right, this is where I'm saying it kind of goes hand in hand, and there's some things you're going to do for lab with this. It basically says then take the different regions of the body and name the structure in each of the following regions. I'm going to make sure, or let me say, I'm going to point you to where you can find that if you haven't already done it. When it says the cephalic region, it's basically talking about the head. Name the structure in each of the following regions. Sorry, I had to admit some people. Okay, so when we're talking about the cephalic region, this would be that picture that they show, whether it's on visible body or you can do it in OpenStax, or you'll do it in the lab where it shows the front and the back of the person and labels the different specific anatomy term for with the general term. So let me give you an example, make sure that you understand what we're talking about here. All right, as it goes through this and it talks about it, it's showing that picture of basically a person standing there. And when they say frontal, when saying name the structure that are in frontal, just means forehead. Orbital just means eye. Buccal just means cheek. Nasal means nose. Oral means mouth. Mental means chin. Auricle means ear. So it's acid. So again, that picture is in your OpenStax book, or you can do it on visible body. You should be able to work through each of those. All right. I am going to mention that parietal and zygomatic, those are a little odd. I won't hold you accountable for those because they're very specific structures. They're actually much more specific than just a head. Parietal is talking about generally areas of the brain and certain structures specific to the skull. And the zygomatic is, again, a very specific structure that's on the skull. So I don't usually hold you to those two. You can do the same type thing for thoracic or the back. It's asking you to find, and again, you can use visible body. You can use your OpenStax ebook. Early on, and it'll label most of these. Again, as an example, axillary is talking about an armpit. So all it's asking you to do for this section is make sure that you know the term for the general structure, or you can name the general structure and the term listed here. Okay, I think all of these are pretty straightforward. If you have a question about any of them, again, just reach out, let me know. Again, I think this stuff that it goes through in that lecture that's on visible body is stuff you'll also overlap in here in lab. So this is that 2-for-1 type thing. All right, which gets me to lecture 2. And talks about body cavities and quadrants and whatnot. And so this is then where I can go back to the lecture where I'm going to build and wander through some things that allow you to come through visible body and answer some of these questions. So if you didn't get to this, and as you were working through visible body, this is listed as lecture 2. What I'm going to do is do this, do the lecture I have so that you can then try to work through this lecture portion too. So I'm going to try to work through and answer some of these questions for this next section. Does that make sense what I'm saying? Is that all right? Okay. So, okay. The next lecture basically hones in on a couple of things that still relate to the body and terminology and things like that. One of the things, though, that I don't think is discussed in that area, but we use oftentimes is that you are compartmentalized, all right? When I do this lecture in class, a lot of times I talk about there's some themes of the body. Well, one of the big themes of the human body has to do with compartmentation, all right? You are divided up into compartments. Now, there's two main compartmentation the two types of ways we can compartmentalize you. We can talk about the water compartments of the body, and we can talk about the body cavities of the body. So you are compartmentalized because of your water. You're also compartmentalized because of the different body cavities. All right. So if you think about humans, if you think about, well, living organisms, a lot of times, a lot of what makes us up is water. We are about 60% water. So if I took everything that makes you up, all your cells and tissues and all that kind of stuff, you are compartmentalized based on your water. And you are about 60% water, give or take a little, depending on if you're male and female. Well, the important part here is that we can take those water compartments and talk about what you find inside your cells versus outside your cells. Okay. And so I kind of want to describe that for a second. All right. Now, when we talk about the water compartments, there are two main water compartments. We can talk about intracellular and extracellular. Well, here's what we mean. If we added up all of the water in your body, then you are about 60% water. It is divided up into two main compartments, the intracellular, and we call the intracellular the ICF, intracellular fluid, and this accounts for about 40 of that 60%. There's also the ECF, the extracellular fluid. It accounts for about 20% of that 60% that makes you up. Okay, now this should be straightforward. I'm going to draw a different way. You have, this goes back to middle school. You are made of cells, right? Cells of the body. We think of them as little circles. They have a nucleus and the other organelles. And you've learned about cells for a long time. Here's what we mean. When we say the ICF, inside the cell, the water inside the cell, the water inside the cell. Back in your basic biology, you probably learned about that as your cytoplasm, the fluid in your cell. That's the ICF. All of this outside here is the ECF. All right, extracellular fluid. Well, the extracellular fluid can be subdivided into two main subcategories. Your extracellular fluid can be interstitial. So of this 20%, about 15 is interstitial. So technically speaking, in my picture right here, this ECF I have drawn is interstitial. It is the fluid that bathes your cells. Your cells are suspended in a fluid. That is the ECF, or interstitial fluid. All right, your plasma accounts for 5% of your extracellular fluid. It is a specific fluid of your blood, the fluid of your blood. All right. Hopefully that makes sense. If not, reach out, let me know. So you have that which is inside your cell, that which was outside your cells, and if you added all of that up, it accounts for the water, or 60% of the body. 40% here in the ICF, 20% in the ECF, and this ECF can be subdivided again into your interstitial, which accounts for about 15%, and your plasma, which accounts for about 5%. All right. As we mentioned already, the body can be divided into regions and planes. We already did the planes, so we can do the two main regions. They are your axial and they are your appendicular. Your axial in this picture is everything you see in blue. It is your head, it is your vertebrae, your spine, if you will. It is your rib cage. It goes down through the sacrum and the coccyx here, but it ends up making a portion of your pelvis. That's your axial. We think of it as the head and your main trunk. Your appendicular is what we think of as your appendages, your arms and legs. All right. Those are all in pink here. Okay, those are the two main regions. You'll learn much more about that as you go into lab. All right, in addition to the water compartments, you have the body cavities. All right. We compartmentalize you, and you are compartmentalized into these water compartments and these body cavities because of functioning. All right. You are compartmentalized, whether it's a water compartment or whether it's a body cavity, so that you can control and organize functioning. All right. I'm going to try to give a simple example. Take your grocery store. You go to your grocery store so that you can get groceries. Let's take Walmart. All right. Now, it is divided up, right? You've got the grocery portion of Walmart. There's then a portion where you can get clothes at Walmart. There's an outdoor section of Walmart. There's even an automotive section of that super Walmart. There's a television and electronics section. All right. Look, I'm pretty sure you don't find the milk over there in the outdoor section. You don't find the milk over there in the electronics section. Walmart is compartmentalized. And that is because you find the TVs where they function and they work together over there. Same thing is true of groceries. And so the point here is you are divided up that same way so that you can separate and organize functioning. Okay? There are two main body cavities. We think of them as the front body cavity and the back body cavity. We could say the anterior and the posterior. Another word for that would be dorsal or ventral. All right, here in the picture, your dorsal body cavity. The dorsal body cavity is your posterior body cavity. It includes the cranial cavity here and your vertebral or spinal cavity. So your dorsal body cavity is subdivided into a cranial, and the cranial cavity contains your brain. It is subdivided into a vertebral or a spinal, that's what's going down through here, and it contains your vertebra and spine. So these are included within your dorsal body cavity. Your other body cavity is the front side, ventral, anterior. So there's also a ventral body cavity. You will note that the ventral body cavity is subdivided again. Your ventral body cavity is divided into an upper or superior thoracic cavity. So again, this is where we use terminology. The thoracic cavity is superior to the abdominal cavity. Okay? Your thoracic cavity can also be further subdivided. So if we zoom in now, we've got a ventral cavity divided into a thoracic and an abdominal cavity, or sometimes you see abdominopelvic cavity. I'll get to that. All right. But your thoracic cavity can be further subdivided. Whoops. Your thoracic cavity. So now if I zoomed in and tried to say, okay, look, you have your thoracic cavity. Your thoracic cavity is part of the ventral cavity, or what we think of as your chest. All right. So if this is the thoracic, that is part of this ventral cavity, then it can be divided or further divided into cavities. All right. There is a right and a left pleural cavity. A right and a left pleural cavity. I'm going to show you a picture below. The pleural cavity is where you find your lungs, though you have a right lung and a left lung. The mediastinum is a centralized cavity. I don't cover it a whole lot, but it is basically down through where you would find your breastbone, your sternum, if you will. There's an upper and a lower mediastinum. All right, so it is a centralized, medial, in the middle, if you will, cavity. All right, several organs go through there, that mediastinum, your esophagus, your throat, things like that. Within the mediastinum, there is a pericardial cavity. Your pericardial cavity within that mediastinum is where you find your heart. So again, looking at here, we have a ventral body cavity. You have a thoracic cavity divided into a pleural, a right and left pleural. You have a mediastinum. Technically, there's an upper and lower mediastinum. And within that mediastinum, there is a pericardial cavity, a cavity where you find the heart. Your ventral body cavity can also be then divided into the abdominopelvic cavity. This is where you think of as your abdomen. Ooh, when you're working out, you're trying to get your six-pack through there. That is your abdominopelvic cavity. Your abdominopelvic cavity, all right, is separated from your thoracic cavity by the diaphragm. So if we were drawing this out, looking at that, you have a ventral body cavity that is made up of a thoracic, a superior thoracic cavity, and an inferior abdominopelvic cavity. The thing that separates the thoracic from the abdominopelvic is the diaphragm. So when we get into the abdominopelvic cavity, you will note that your abdominopelvic cavity is divided into an upper abdominal and a lower pelvic cavity. all right? Your abdominal is the majority of your abdominopelvic cavity. It is your abdomen, and it is where you would find your stomach, your liver, your spleen, the intestines, all of your large and small intestines, if you will, your viscera, all your guts. And those scary movies that you're cut open, mostly when you're cut open in the abdomen, what spills out from the abdominal cavity. All right. The pelvic cavity is the lowermost cavity. It is essentially, if you put your hand on your hips, it's that area. The pelvic cavity is basically where you find your groin area, or it is basically your reproductive organs and your bladder for the most part. Okay, that is those. Okay, so that we're easing into things, I've lectured and introduced stuff for about an hour. Okay, for next week, I want you to continue working through visible body. And this lecture part 2 that wanders through some of that stuff I just mentioned, as well as start looking at the different membranes within your ventral body cavity. So that when I come back on Tuesday, all right, we're going to hit some of these highlights real quick, and I'll be able to get into cells. We're rapidly, if you will look at that syllabus, approaching that first little mini test. All right. I'm going to quickly mention membranes. Your serous, the ventral body cavity is made up of serous membranes. It is a double-lined membrane that surrounds the organs within the ventral body cavity. All that's basically saying is if you have an organ in the ventral body cavity, take for example, there is a heart. Remember, it is in the pericardial cavity. All right. There's a double-lined membrane that surrounds it. It is a serous membrane. So your heart is surrounded by a double-lined serous membrane, 2 layers. The parietal serosa is the outermost membrane. It lines the cavity, if you will. The visceral serosa, it is the inner most serosal layer. It's closest to the heart. It's touching the heart. I can use my terminology again. Look, your parietal is superficial compared to your visceral. Your visceral is deep compared to your parietal. Look, because this is close, one, closer to the surface, closer to the outside. That's what superficial means. Deep, deeper to the surface. Okay. So those are those 2. They are separated, because it's a double-lined membrane, by serous fluid. The serous fluid is the fluid that occurs between your parietal and visceral serosa. It allows for your organ, your heart, and other organs to function in a, frictionless environment. It means it doesn't create a blister, if you will. It doesn't rub together. All right. So I'm stopping there because now I want you to work through and look at specific examples of the serous membranes in terms of a parietal pericardium, a visceral pericardium, a parietal pleura, a visceral pleura, a parietal peritoneum, and a visceral peritoneum. You may be doing this in lab, or you may already have done this in lab. And so when we come back next time, we'll hit some of these highlights and start working through some more of that lecture on visible body. What you'll see on there, if you look through those guided notes, it'll talk about homeostasis and positive and negative feedback. And that's going to be what I'm working towards. I want you to look ahead at that information though, so that I can go through it quickly. If you have questions about it, then let me know. All right. So we're working through doing some lecture stuff. I'm asking you to do some things, look ahead, again, sort of think about it as looking ahead, having a basic overview and answering the questions you can. All right. That's going to be good practice that then we build on here. Okay. That's all I have for the day. Stop the recording, but I'll hang out for a second in case people want to jump in with questions.